Hello everyone, welcome to lesson 1 of Mastering Ethereum. We are diving into the exciting world of blockchain technology, breaking down its components, benefits, and applications in an easy to understand way. Let's get started. First major question which pops in your mind is what is blockchain? Blockchain is a cutting edge technique for securely storing data in a way that is decentralized. Decentralization ensures that the blockchain is not governed by an individual, group, or even the government. Imagine it as a massive public notebook shared among countless people around the world. Everyone can read what's written, but once something is added, it can't be erased or modified, and no specific individual controls it. One such example is considering a shared public document where everyone can make entries, but those entries are permanent and transparent to everyone. Blockchain is a distributed ledger, that is, it is a secure way of conducting and recording transfers of digital assets without the need for central authority while maintaining transparency. The transfers or transactions are governed by a consensus mechanism. Consensus mechanism ensures that all participants in a network agree on the validity of transactions and the state of the ledger. There are different consensus mechanisms such as proof of work, which is being used by Bitcoin, proof of state, proof of history, proof of authority, details of which will be discussed later. A blockchain consists of sequentially connected blocks, which are files stored on the blockchain where transactions are recorded. Each block contains transactions, which are data exchanges between participants, a hash, which is a unique fingerprint identifying the block, a previous hash, which is a link to the block before it, and a timestamp, which contains the date and time the block was created. Think of each block as a page in our giant public notebook, where every page has a unique page number and refers to the previous page number, which is the previous hash. Here are some of the terms related to the blockchain ecosystem. Firstly, the nodes. Nodes are computers participating in the network, storing copies of the blockchain. Miners are special nodes verifying and adding transactions. Think of miners as accountants who ensure that each entry in the notebook is accurate. Wallets are tools for managing cryptographic keys. Keys authorize the transactions securely. These are like digital lockers for your signatures or passwords to access the shared notebook. Applications are software built on blockchain for specific functionalities. These include financial transactions, supply chain tracking, and healthcare data management. These are like different apps on your phone tailored for banking, shopping, and health records, but all are built on blockchain for transparency and security. For instance, let's consider a real-world example involving cryptocurrency. When Alice wants to pay Bob one Bitcoin, the transaction initiation is akin to Alice writing in the shared digital notebook. This transaction is then broadcasted to the network for verification by miners who check it using Alice's wallet. Once verified, the transaction is recorded in a new block on the blockchain. Here are some key benefits of blockchain. Once data is recorded, it can't be altered. Ledger is permanent and tamper-proof. Its history cannot be modified or changed after its creation. This is known as immutability. It provides for maximum data integrity as the transaction can be traced back to their origin. It is similar to writing with permanent ink in a notebook. All transactions are visible to everyone on the network, accounting for transparency. For example, everyone can read every page of our notebook at any time. Blockchain uses advanced cryptographic principles to protect the network. Think of it as a notebook being protected by an unbreakable code that only authorized participants can interact with. There is no central authority, hence there is no single point of failure. It is like there are multiple copies of our notebook that are stored all over the world, so if one is lost or damaged, others keep the information intact. These key features of blockchain greatly differ from traditional databases which are centrally operated, creating a single point of failure. Also, the data is mutable, hence there is a breach of data integrity. Data integrity is the maintenance of and assurance of data accuracy and consistency over its entire life cycle. Let us now look into steps for adding transactions to the blockchain by recalling the example of Alice and Bob. A participant initiates a transaction. This is called user request. Alice wanting to pay Bob one Bitcoin is a user request. The transaction request is sent to the entire network referred to as broadcasting. Alice announcing her intent to all her friends in the network is broadcasting. miners check the transaction for legitimacy. This is called verification. Our accountant friends verify if Alice really has 1 Bitcoin to give to Bob. Once verified, the transaction is added to new block and attached to the blockchain through block formation. Alice's payment to block is written on a new page in the notebook. This is an example of block formation. Let us now go into details of consensus mechanism, which maintains the security of blockchain by keeping a record of all legitimate transactions. Proof of work consensus mechanism is where network members solve computational puzzles to validate transactions, which is energy intensive. On the other hand, proof of stake is where validators are selected based on the amount they have invested in the network, making it more energy efficient. Let us understand this with an example. Those with more trust or investment in a notebook get a higher chance to verify new entries rather than the ones which are less trusted. There is also proof of history in which order of events is crucial as the events themselves, and proving this order is a vital upholding for the network integrity. Let us now look into some real-world use cases of blockchain. In finance, there are cryptocurrencies, which are digital forms of money like Bitcoin. Bitcoin allows Alice to securely and transparently pay Bob without needing a middleman like a bank. It is used for secure and transparent banking transactions, reducing fraud and increasing trust. It can create smart contracts, which are contracts that are automatically executed when predetermined conditions are met. For example, an automatic rental agreement where the payment is released once the tenant receives the keys. Another such use case is supply chain, for tracking a product's journey from its origin to consumer. It is also used for monitoring and managing the shipment process across the entire supply chain. It is used for counterfeit prevention by verifying the authenticity of products to avoid counterfeits. Think of it as ensuring the designer handbag you bought is genuine. It aids in auditing for compliance and efficiency. Here are some applications of blockchain in healthcare. It keeps a track of patient data across different providers. It can also keep a track and validate drug authenticity. It can ensure immutability of clinical data for transparency and also verifying credentials of medical practitioners. Let us look into some of the leading blockchain platforms. Each platform provides unique features and have their own pros and cons. Bitcoin is the first blockchain focused on cryptocurrency. It uses the proof of work consensus mechanism and was launched in 2009. Ethereum is the platform that supports smart contracts. Initially, it used the proof of work consensus mechanism and is now transitioning to proof of stake. It was launched in 2015. Hyperledger Fabric is an open source enterprise blockchain platform that supports the proof of authority consensus mechanism, which uses identity as a stake. For example, businesses use Hyperledger to build custom blockchain applications for supply chain management. Although blockchain has advanced too much in these years, there are certain challenges and limitations it is facing, some of which are handling high volumes of transactions is still a challenge. Different rules and regulations across various regions can complicate the blockchain implementation. Overcoming resistance to a new technology can be difficult. Think of it as getting everyone to switch from old paper-based notebook to a new digital one. Making blockchain technology easy for everyone to use is still an ongoing process. Blockchain is regarded highly due to its security. Blockchain is secured due to private keys, which are essential for authorizing transactions on the blockchain. It's crucial to safeguard private keys securely to prevent unauthorized access or transactions. Hashes are used to uniquely identify blocks in the blockchain. The cryptographic nature of hashing makes it extremely difficult to alter or modify data within the blocks. Consensus mechanisms like proof of work, proof of stake, ensure that all the nodes in the network agree on valid transactions. Here is a blockchain trivia which you may read and increase your knowledge through these interesting facts. Blockchain is constantly growing and will keep growing in the future due to increased global engagement across industries such as finance and healthcare. Innovative blockchain-based solutions are continuously emerging. Examples are new applications like decentralized finance platforms. Scalability is being increased by working on overcoming current hurdles related to processing of large number of transactions. Governance models are being made for establishing robust governance for decentralized systems to ensure fair management. If you have enjoyed the lecture so far and have gained basic understanding of blockchain, let us now summarize this lecture through some key takeaways. Blockchain offers secure and transparent sharing of data. Example, everyone can see all transactions in our public notebook. Once data is added, it cannot be altered. That is, it is immutable. The technology enables new applications across various industries. Blockchain is still in its early stages with a significant potential for growth. This brings us to the end of our lecture. Thank you for spending your valuable time.